On June 8, 2026, a satellite passing over the equatorial Pacific measured something that made scientists sit up immediately. Sea surface heights running more than 15 centimeters above normal across a wide stretch of open ocean. That measurement mattered because of what it revealed that surface temperature readings alone cannot show. A massive reservoir of heat had already built up beneath the ocean's surface, invisible from the top, and it was still growing. 3 days later, on June 11th, NOAA made it official and declared a new El Niño. But here's the part that's drawing serious attention from climate scientists right now. The satellite data had already caught the signal before the official declaration, and what it showed wasn't a routine garden-variety warming event. It showed a Kelvin wave of extraordinary scale moving west to east across the Pacific, building toward what a growing number of researchers are now calling a potential Super El Niño. And simultaneously, in the waters off the North American west coast, the return of a marine heatwave phenomenon known as the Blob, the same pattern responsible for one of the most disruptive ocean events of the past decade. Today, we're breaking down exactly what the satellites caught, why the timing and scale of this signal genuinely surprised the scientific community watching for it, and what a Super El Niño combined with a returning blob actually means for weather, fisheries, and coastal ecosystems across the entire Pacific Basin and well beyond it. Drop a comment right now. If you live along the Pacific coast or you felt the effects of a past El Niño or La Niña event where you are, tell me about it. And if you want the update the moment this pattern develops further, subscribe right now. It's free. A thumbs up helps enormously. Let's get this to 5,000 likes so it reaches the people who need to see it. Now let's get into it. What the satellite actually caught. To understand why this specific detection mattered, you need to understand what makes El Niño genuinely hard to see coming using surface data alone. El Niño is officially declared based on sea surface temperatures in the central and eastern equatorial Pacific, holding at least 0.5 degrees Celsius above average for several consecutive months, a threshold NOAA confirmed had been met on June 11th. But sea surface temperature is, in a real sense, a lagging indicator. It tells you what's already happened at the surface, not what's building underneath it. Satellite altimetry, the technology used aboard the Sentinel-6 Michael Freilich satellite, measures something different and, in this context, more revealing: sea surface height. Warm water expands and takes up more volume than cool water, so a rise in sea surface height across a wide stretch of ocean is a direct physical signature of heat accumulating in the water column below, even before that heat fully surfaces and shows up in temperature readings. When Sentinel-6 measured surface heights running over 15 centimeters above normal in early June, it was detecting a genuinely enormous subsurface heat reservoir that had already formed, one that satellite tracking had actually been following since early spring, when the first pulses of warm water began crossing the Pacific from west to east. That west-to-east movement of warm water is what oceanographers call a Kelvin wave, a large-scale oceanic wave that travels along the equator and is the fundamental physical mechanism behind every El Niño event. What made this specific Kelvin wave notable wasn't that it existed. Kelvin waves happen with some regularity. But its scale and the speed at which the associated heat reservoir built up beneath the surface, tracked continuously by the satellite, from its earliest stages through the point where surface conditions finally caught up and met the official declaration threshold. Why Super El Niño is the term scientists are actually using. El Niño events exist on a spectrum, ranging from weak events that barely register outside of technical climate reports to genuine Super El Niño events capable of reshaping weather patterns across multiple continents simultaneously. The 1997, 98, and 2015-16 events are the two most widely referenced Super El Niños in recent memory, both associated with major global disruptions to rainfall patterns, drought, flooding, and extreme heat across widely separated regions. What's pushing researchers toward using that specific term for the 2026 event is the combination of the subsurface heat reservoir scale, confirmed through the satellite data, with NOAA and the World Meteorological Organization's own confidence assessments. Both agencies have placed the probability of El Niño continuing into early 2027 above 95%, with a very strong event now considered increasingly likely, specifically through the October to December window, the period when El Niño's global effects typically reach peak intensity. That's an unusually high confidence forecast this far out, and it reflects how clearly the underlying ocean heat signal has continued to build rather than plateau or weaken since the initial detection in June. The blob returns at the same time. Here's where this story becomes genuinely more complex than a single climate pattern developing on schedule. At the same time, this Pacific-wide El Niño signal has been building. A separate and specifically regional marine heat wave, nicknamed the Blob, has been reforming in the waters off the North American west coast, stretching from California up through Oregon, Washington, British Columbia, and into the Gulf of Alaska. The original Blob event, which persisted from roughly 2013 to 2016, caused significant, well-documented disruption to marine ecosystems along the entire West Coast, including major disruptions to fisheries, harmful algal blooms, and mass mortality events among marine mammals and seabirds that struggled to find food as the fish and plankton populations they depend on shifted in response to the unusually warm water. Researchers monitoring the Eastern Pacific say the current marine heat wave has developed rapidly, with satellite observations showing unusually warm surface water spreading across a vast stretch of ocean, in some areas measuring several degrees above seasonal norms. These warm water masses function, in a real physical sense, like atmospheric heat domes, but sitting over the ocean surface instead of land, trapping energy in the upper water column and altering the marine food web from the bottom up. The concern among researchers is not simply that the blob is returning, but that it's doing so at the same time as a Super El Niño is developing across the broader Pacific. Two warming mechanisms operating simultaneously, rather than the kind of single, isolated marine heatwave event that's easier to study and forecast in isolation. Why the combination is what actually worries scientists. An El Niño event and a blob-style marine heatwave are not the same phenomenon, and they don't always occur together. El Niño is a basin-wide shift in Pacific Ocean temperature and atmospheric circulation patterns driven by that Kelvin wave mechanism moving heat across the equatorial Pacific. The blob is a more regionally concentrated marine heat wave along the eastern Pacific margin, driven by a different combination of persistent high-pressure ridging and for reduced wind-driven ocean mixing that would normally bring cooler, nutrient-rich water up from the depths. When both occur simultaneously, their effects don't simply add together in a predictable way. They can reinforce and amplify each other, particularly along the West Coast, where El Niño's typical atmospheric pattern shifts can further suppress the wind patterns that would otherwise help break up a developing marine heat wave. This is precisely the combination that concerns the researchers, tracking both signals right now. A strong El Niño alone reliably reshapes global rainfall and temperature patterns for a year or more. A blob-scale marine heat wave alone reliably disrupts West Coast marine ecosystems and fisheries for years, as the 2013-2016 event demonstrated. Both developing at once raises the realistic possibility of compounded impacts along the Pacific coast specifically, on top of the broader global effects a Super El Niño produces on its own. What this actually means beyond the ocean itself. El Niño's influence reaches far beyond sea surface temperature. During a strong event, the shift in Pacific atmospheric circulation reliably alters storm tracks, rainfall distribution, and temperature patterns across a huge swath of the globe. It tends to reinforce drier conditions across parts of Southeast Asia, Australia, and Southern Africa, while often bringing wetter conditions to parts of South America. It also tends to reinforce the kind of high-pressure blocking patterns responsible for prolonged heat waves in the mid-latitudes, patterns that have already driven extreme, record-challenging heat across Europe and parts of Asia throughout this year. A strengthening Super El Niño layering on top of that existing pattern through the back half of 2026 raises real questions about whether the extreme heat events already affecting South Korea, Japan, and South Asia this summer could see their underlying atmospheric drivers reinforced further as the El Niño signal continues to strengthen into the autumn. Marine ecosystems face their own distinct set of consequences. Warmer water holds less dissolved oxygen and shifts the distribution of the phytoplankton that form the base of the entire ocean food web. NASA's PACE satellite mission is specifically being used by researchers right now to track how phytoplankton communities across the equatorial Pacific are responding to this developing El Niño, data that feeds directly into fisheries management decisions across the Pacific Basin, since major commercial species like tuna depend heavily on the food web dynamics that shift dramatically during a strong event. The honest uncertainty in all of this, it's worth being clear about what's confirmed and what remains a developing forecast. NOAA's June 11th declaration of El Niño is confirmed, based on sea surface temperature data that met the established threshold. The satellite detected subsurface heat reservoir, and its unusual scale are confirmed physical measurements, not speculation. What remains a forecast, carrying real but not absolute confidence, is exactly how strong this event ultimately becomes by its peak in the October to December window, and how significantly the concurrent blob-style marine heat wave interacts with and amplifies the broader El Niño signal along the West Coast specifically. The greater than 95% probability NOAA and the WMO have assigned to El Niño's continuation reflects genuinely high confidence in the pattern's persistence, but the precise magnitude of its downstream effects on West Coast fisheries, on global rainfall patterns, on how much it reinforces the heat events already underway across Asia and Europe, will continue to sharpen as more data comes in over the following months. What to actually watch for next. Researchers tracking this pattern will be watching whether the subsurface heat reservoir detected by Sentinel-6 continues to feed sustained warming at the surface through the back half of the year, whether the Blob-style marine heat wave along the west coast continues to intensify or begins to break down as autumn storm patterns typically start to reestablish, and how strongly the developing El Niño signal reinforces the atmospheric blocking patterns already responsible for extreme heat across multiple continents this year. NOAA's Climate Prediction Center issues regular updated ENSO diagnostic discussions specifically tracking this progression, and satellite monitoring through Sentinel-6 and its eventual successor will continue providing the subsurface data that gave scientists their earliest warning of this event's true scale back in early June. The Pacific Ocean sent a genuine warning this year, and the striking part isn't simply that El Niño returned, it's that satellite technology caught the true scale of what was building beneath the surface before the surface data itself could confirm it. And what it revealed was a heat reservoir large enough to push a meaningful portion of the scientific community toward the term Super El Niño, well before the event has even reached its projected peak. Layered against the simultaneous return of a marine heat wave pattern that already caused years of documented ecological disruption the last time it appeared, and set against a year that has already produced historic heat records across South Korea, sustained extreme heat across South Asia, and record-challenging conditions across Europe, this is a genuinely significant ocean signal arriving at a moment when the systems it influences are already under real strain. We'll keep tracking this closely as the event develops through the rest of the year. Subscribe so you don't miss the update the moment new data comes in. And drop that comment. Tell me if you've lived through a major El Niño or La Niña event before and what it looked like where you are. Let's get this to 5,000 likes so it reaches the people who need to see it. See you in the next one.